diameter. That's why the skills of Kung Fu gone missing nowadays, okay? You get all the BS coming out. Okay, right? So that is the shaft that we are going to size, okay? Then we have our gear. I think I'm just going to draw one more gear and no more answering about the Kung Fu anymore. Yeah, we are done. Right? So now, this is gear number D. Okay, so this is gear D. And I want you all to focus on gear D. Right? I want you all to focus on gear D. So that's our gear D. You know what? I should put this in a different color. This one. Okay, that's gear D. Right? So you all can see that this is gear D. And gear D is going to transmit power to gear H. So I'm going to draw gear H down here. Okay. Okay, so this is gear H. Right? So remember, I asked you guys to focus on the point of contact, yes or no? We have identified a point of contact. So what is missing? I did not draw gear G and gear C, okay, because it makes the diagram too messy. Now, question for it. So at the point of contact, now this is where it is critical. You get this wrong, man, the whole analysis is down the toilet bowl, the sink, or whatever, okay? Now, question for you. Between gear D and H, is the force going in this direction, or is it going this direction?
Left.
For, huh?
To the left.
Into the left. Anyone else?
To the right.
To the right, to the right. To the left. Do you all know that song? Yes or no?
Yeah.
Yeah. Okay. Anyone else?
Left.
Left. Okay. So the right answer is okay. Let me tell you the problem. Couldn't let apprentice learn the wushu. Okay. So let's say it's going to the left. Okay. So the plot, not the plot. So if this FE is our input, you mean to tell me that our output is in the same direction? I mean, when I say same direction, generate a rotation in the same direction. Right? So if our output, if our current output, okay, is that direction, means the load is going to help the motor. Does that make sense? Right? The load. So where is the load? This is at this point, this is our resistance. Right? At that contact point, they have to have resistance, yes or no? So if you look at the diagram over here, right? If you look at our question diagram over here, where is it? Right? You mean to tell me at this point, right? Right? There's resistance, and the resistance is going to be in this direction, means it's going to help FE. What do I mean by help FE? Is because you are telling we are saying that, okay, it is going to rotate in this direction, which is the same direction as the what? As gear E, and gear E is also our input. So now, after me describing this, what direction it should be? Or you don't, you are not getting it yet. Do you get it or no? Does it make sense?
To the right?
Yeah. So the correct answer, okay, the correct answer is this. Right? So this is the output force. Okay, right? So how to gauge this? Okay, how to gauge this? So Fe, the input, right, based on the force, right, will induce a rotation in this direction. So this is input direction. The output should be a what? A resistance, yes or no? So the output. So if you are not sure, you just look at the rotation. So you concentrate on gear D. Okay, you concentrate on gear D, and this is the me and my color blind. If anyone know how to fix color blindness, tell me. Okay. Okay. So over here, right? This is the output rotation. Because it's resistance, yes or no? That is why the output force has to oppose. Someone has unmute and has a question to ask. Anyone?
Yeah, sorry. Aren't those two gears, D and E, on the same shaft and therefore spin in the same direction?
D and E. Yeah, D and E are in the same input rotation, right? You're absolutely right. But at point D, or at the contact where output force is going to resist the what? It's going to resist the rotation.
And that's because it's an output?
Yes.
Okay.
Right? Because we can okay. Let me back up my horse a bit. Maybe I'm not explaining properly. So at the end of the day, you're absolutely right. Okay, the shaft will rotate based on the input rotation, but there has to have resistance. Yes or no? The resistance are coming from what? So I would or output, or I call this output bracket resistance. Right?
Gene?
Yes.
Would the same thing happen at C and G as well?
Yes.
Okay.
So the resistance, okay, the output resistance rotation will oppose the what? Input. If we say that it's the same, means the resistance is helping the motor. You get what I mean? Right? It is in the opposite direction. Are we okay now? Yes or no? Are you okay? If you're not clear, please let me know now. Okay, before I go on, I'd like to apologize, okay, to students that did not get this answer right. I do apologize, okay? I think I'm getting high or tired, okay? I do apologize. By no means I want to embarrass you or whatsoever. If you do, listen, I apologize. I'm sorry, okay? Right. No answer yet. Okay, it's okay. I feel very guilty now, okay? Please accept my apology. Right. So coming back from here, right? So the big thing to learn down here, okay? The big thing that I want you to learn down here is this, okay? I'm going to write all this down so you all can remember. Okay, determine the force direction at the gears and the analysis, okay? Yeah, right now the analysis is this: the force is controlled by the input gear. Okay, and then I'll write this further. The output gear force direction will always oppose the input gear force, right? So i.e., once you see this diagram over here, okay, we know that it's not this direction. You are absolutely right. The rotation that the shaft will rotate is this way. But the resistance, okay, so I'm going to use like really like the resistance, okay, so these are the what? Resistance. will always be in the opposite direction. And based on the rotation, what you see now is that the resistance will go this way. Okay, the resistance will go this way. Okay, the resistance will always be applied in the opposite rotation direction compared to the input gear or input shaft or input gear for this case. Okay, so therefore from here, now this is important. Okay, this is important because if we get this wrong, right, what is going to happen is your analysis will just go down the toilet bowl. Okay, so that is where if you look at the textbook, okay, so which you guys have this figure here. Okay. We have sorted this out. So this is from the textbook. Okay, this is from the textbook. Okay. So from textbook, right? This is how the forces are written. Okay, and now you know why. Okay, I know it's just two lines. I know it's just two arrows. Okay, those two. Okay, Eugene, it's just two arrows. Move on. But you have to analyze the what? The valid direction. So this is correct, right? This is correct. Now, regarding point A and point B, we don't know. Okay, I repeat again, regarding point A and point B, we don't know yet. Okay, so now from here, where do we go? Okay, from here. So from here, we're going to find the power. Okay, we're going to find the power. So the next thing we're going to do, before I go on, for this case, right? This is only to analyze the force. Okay, analyze the force direction at gears contacting points. Okay, right. You know what? I'm going to stop here. Okay, I think you guys had enough of me for today. Okay, so I'm going to stop here. And the good news is, this week, what can I say? There's no homework for this week. Okay, so just take a good break, have a good rest, and I'll see you guys next week. Again, next week there is no quiz. Okay, because there's not enough material for the quiz. Other than that, thank you for your time. Thank you for your attention. Have a good weekend, and I'll see you guys next week then. Bye-bye. I'll still be around if you have any questions, okay? I'll still be around if you have any questions.
All right. Thank you, Professor.
Bye.
Eugene, I have a question about Tresca.
Okay.
It's-
Let me stop recording first, okay?
Okay.
Let me stop recording first.